Hey, so in today's video, I wanted to show you how to do image-to-image style transfer. I was searching around on TensorFlow and found this tutorial, and I thought it'd be a really good just project to show you guys. It's really good for beginners, mainly because they've written most of the code out, and you can just use it in Google Colab and play around with it. So by the end of this video, you'll be able to load some of your own images and turn them into new styles or apply a new style to them. So let me just jump into the computer and I'll show you what I mean. All right, so we're in the computer. This is my Jupyter notebook here. I've downloaded the file as a notebook, but you can see that there's all these different other types of abilities to run the file. So if you don't have a computer that can, if you don't have your own environment set up, you can run it on Google Colab. So it's the same thing, but it's just, I have mine locally installed and you can run yours in the cloud. So I'm going to skip over all of this. It's just sort of explaining what the point of the book is. But basically, let's say you have a picture of your dog and you wanted to ruin that picture by applying a Kandinsky style to it. You might end up with something like this. So we're going to do the same concept. I'm going to take a picture of myself. We're going to apply a Drew Struzan style poster to it and see if I can get myself to look like I was painted by the great Drew Struzan. So to set up, we're going to import our dependencies here, our packages. So TensorFlow, obviously. One thing I should say is I did not write any of this code. This is literally just copied from TensorFlow. This is just a way for me to show you guys what's possible, what's just out there sitting on the internet for you to just do. It's pretty amazing. So basically what we're doing here is we're importing our packages. Tensor to image is creating a tensor shape, and it's going to return an array for that tensor. That's important because it's going to take sort of the, like vectorize the image. And if you're a beginner, don't worry about what that means, but we're going to be passing through images here. So next we're going to download some images. And what's nice about this notebook is it uses a lot of Keras. Keras is great. We're going to do utils get file. It's a little bit different from your standard get CV, your pandas workflow. But basically, if you had something on the internet, you could just call the name of that file and then link the file path to it. So if you're on local like me, you just sort of have to do a different type of syntax. We're going to make a function that loads our image and makes it into 512 pixels. That's really important. And then we're going to make another function that shows our image. And here we go. So this is a picture of me, a little baby me, when I was like, what am I in this photo? Like 12, something like that. And this is some artwork from Blade Runner, which was painted by Drew Struzan. He's like a famous film poster creator. He did all the Star Wars posters. He did The Thing. John Carpenter's The Thing. Really cool artist. So I thought we could try to put myself in sort of this neon style here of Blade Runner. So you're going to need to also install TensorFlow Hub. And what's cool about this is if you install Hub, you can just like almost like an API call models on your images here, and it just spits out a really fast and dirty stylized image. So if you really wanted to, you could just like stop right here. And that's pretty psychedelic right there. That's pretty wild. We're definitely going to look at all these eyes in the weird background. That's something I wasn't expecting. So yeah, definitely the model is freaking out a little bit here. Let's see if we can clean it up. So we're going to define the content and the style representations. What this kernel here is doing, it's loading the VGG19. It's basically the model that we're going to be using to apply the style. And when we call this, it's supposed to bring back classifications of what the image is about. And right now it's returning barbell, vacuum, dishwasher, and dumbbell. So this model isn't working very well. Ideally, you would want it to make sure, ideally, you would want it to line up. So in the previous image with the dog, if you ran the VGG through it, because this is such a clear picture of a dog, it's going to get a dog. But I've noticed that when you apply people, the model is not very good. And especially if you're applying like a style of other people. So it's not going to recognize that. So what this is trying to do is find like the styles of certain things in here and apply it here everywhere and apply it to the content image everywhere. So it's not like I'm going to end up looking like Harrison Ford. It's not going to be able to do that. So that's why we kind of get this psychedelic. So it really does work best with paintings like a Kandinsky or a Van Gogh or a Picasso. But regardless, let's push on. So let's try to make this image look a little bit better. What we're doing here is getting the blocks and the convolution layers because we're going to take some middle layers here and disregard these like outside layers. And if you want to read why we're doing that, you can in this notebook. It sort of is just to help with the image classification as it says there. And now we're going to build the model. So we need a function to help put our arrays into the right shape to pass through our model here. So you can see that's what we've done. And this is way too much information here for a beginner, but this is basically the formula that is used to do the style transfer. I'm not going to go into that right now. I'm going to create a gram matrix. And this is a class of several functions here. It's just putting together other things that we've done in terms of like the style layers, the content layers, the VGG is the combination of those. It's also going to call self and the inputs as well. So just not going to go too deep into that. I want this to be a quick video because it's just like fun code that you can download. You don't really have to think about it. You can just run it. So here we go. We have the styles now. So we have the content. We have the styles block convolution layers. We're going to run gradient descent and find the ideal output. Basically, we're setting the learning rate here, the beta 1 and the epsilon. That's just ways to hypertune the model, train the model. This is just applying style and content weights. You don't really want to mess with this in the beginning. Just keep that in mind. And then creating another function called style content loss. And we apply it as a gradient tape to our initial image function. I know that doesn't really make sense, but basically we're making sure we're applying the correct gradient descent on our images because gradient descent sort of determines where the model is most effective. That's like a super basic high overview, but you can look more into gradient descent. It's really important to know in machine learning, but that's outside the scope of this video for now. We're just going to make sure that what we've just applied to our image function is going to work. So we're running it a few times and it should output it. So we can see this is like the very beginning steps of what was happening before. But this time it's a little bit more customized to show it. So it should perform a lot better. So we're going to perform a longer optimization. It's going to do 10 epochs and it's going to have 100 steps per epoch. This might take a while, so if I end up pausing the video, it's because I'm waiting for it to train and optimize. but we'll see. Sometimes it'll do a bunch of dots, tell me where, and then it'll show a picture, and then it'll go through the next epoch, update the picture, and if that's the case, then I'll pause the video. So let's see see how long it's going to take me to get to the first image. It looks like it's going to take a while, so I want to at least show you guys what the first image is going to look like. All right, so you can see this is like the first iteration of the image that it made. That took a long time, so we're gonna have to wait. I'm gonna have to wait for 9 more of those. So I'm gonna pause the video and I'll be back in a moment. All right, we're back, and this is, believe it or not, the optimized image here. You might be saying to yourself, Everett, this looks like garbage. I would agree with you. This looks pretty bad, and I apologize. I should have tested the Blade Runner style photo, but I thought I would just apply like deeper colors or more saturated colors. But clearly this works better with like abstract paintings and whatnot. But regardless, let's keep moving on ahead because there are a few more things that we can do to make this image a little bit better. As this is saying, it creates a lot of high frequency artifacts, and basically what that's saying is there's a lot of noise in this image because it's depth perception. There's a lot of things with the image itself that the model has a hard time sort of deciphering. So to make it easier on it, we create this function here called a high pass. And this part's actually pretty cool. Like it'll show us the horizontal deltas and the vertical deltas of the style image and the content image. And I don't know if you've ever seen these, like back in the day when cell phones first came out, this was like a filter you could apply to certain like photos, and it was sort of weird looking, but it was like, yeah, it was like one of the first things that cell phones had, but this is what it reminds me of. Anyways, you can sort of see where the deltas are, and it gives it a little bit better depth in the image, and these are the horizontal deltas, and this is why the noise is so prominent, because you can just see how wrinkly it is here in the shirts and along the walls and all that. And what is this? Oh, this is the Sobel edges here. So yeah, I mean, the reason we show this, it's just to show you exactly what we're going to be applying to help fix the image. So it's a regularization, and it's through a variation loss, we get the deltas, and we pass it through our image and reduce the sum there. This is what the number is. It's the variation loss of the image there. And we can apply it to here too, and we see the array and make it into a float there. We don't actually have to go through all that, but it just explains sort of what it is that we're going to be attaching to our train step function. So we need to set a total variation weight. In the tutorial, it was 30, so we're just going to leave it at that. We're going to attach the function we just made with the deltas and the high pass through our train step, and then we're going to reinitialize the variable and retrain the model with that included with it. And then we're going to run the optimization one more time. It should be a little bit faster than before because, right, we trained it already. It's already somewhat optimized, and then we just made it a little bit better. So we're going to run through the image again on 10 epochs of 100 steps per epoch. And then this is a function that lets you save the image. I never do, but just you can if you want. So let's go ahead and run this. Chances are we're going to skip through all the training and the epoch stuff. And and I'll just cut to a cutaway screen and then come back when it's all said and done. I don't think we need to see the image update itself. So I'll see you in a second. All right, there it is. Is this any better than what we had before? I think so. Actually, I think this is a lot better than the previous one here. Where was it? Oh yeah. See, this one's pretty noisy, whereas I feel like the colors are a lot better. My face looks messed up, but I think that's sort of expected. As far as like, does it look like Blade Runner? Yeah, I think it does. I mean, again, it's not going to look very good with like the what do you want to say? It's not going to look clear. Like my face wasn't ever going to look clear, but it definitely applied the right colors. It's got sort of a rain effect on it, which I mean, it's very slight. It's not as strong as it could be, but in any case, this is really fun to play around with. I would definitely suggest getting like a Picasso or a Van Gogh or a Kandinsky. Just look up like abstract artists or cubist artists or whatever, and just play around with it. It's pretty simple. It's pretty fun, and I think it's a good tutorial for beginners. And you can definitely tweak it. And yeah, I think that's pretty cool. Any case, I'll leave it there, and I'll see you in the next video. Bye.